When we get it right, it's about so much more than accuracy.
It's about certainty.
The certainty to build,
to create,
and to move forward with confidence.
From our very first steps as humans, we measured the world to understand it.
Since long before the pyramids rose, and through every great leap since,
measurement has really been the foundation of our progress.
Today, measurement doesn't just look different.
It is different.
But its purpose,
That remains unchanged.
it's to give us the power to shape the world.
For over 25 years,
Hexagon's measurement technologies have enabled you to build,
Break records,
To preserve,
protect,
restore,
explore,
to harvest,
extract,
to design,
push boundaries.
break barriers.
To reimagine what's possible.
no matter how success is measured in microns
or meters tall.
From the invisible
To the infinite.
We deliver certainty when it matters the most.
When there is no margin for error,
When the cost of failure is just too great.
our customers rely on one thing:
Trust.
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 Whether that's the trust in the technology,
Trust in the data,
Or simply trust in us.
working together, we're building a world that's more productive, more efficient,
Safer,
and more sustainable.
when we get it right.
we can build a world
Where collaboration
And leads to the extraordinary.
So, when it has to be right,
It has to be Hexagon.
Today, we step into a new era of possibility, where measurement becomes a sixth sense for the world around us, because progress, human or machine, demands precision. Welcome to What's Next. Welcome to Hexagon Live Global 2025.
Please join me in welcoming Ola Rollén.
Thank you. Thank you. Good morning, everyone, and a warm welcome to Hexagon Live 2025. Now, this is a very special Hexagon Live. We've held 12 of those, or these, and this time is the last time ever we meet in this constellation. And secondly, it's 25 years since Hexagon took its first stumbling step towards becoming the leader in measurement technologies. But this time in June of 2000, I traveled to a town called North Kingstown in Rhode Island, and I met a company called Brown & Sharp Manufacturing Company. And we ended that meeting by Hexagon acquiring Brown & Sharp, and that was the first step into the business as you know us today. Now, you're sitting here today and you're thinking, why measurement technologies, right? Or, well, you should be thinking that because I've looked into this business running a hotel in Las Vegas, and that is quite profitable. But you know, all great feats, all great leaps that mankind take involve some kind of measurement technologies. Let's say we want to put a man on the moon. What do you need to know? You need to know the distance to the moon. How big fuel tank should I have to make it back to Earth? And as I'm traveling towards the moon, I want navigation equipment to keep me on track so I don't drift off into eternity. And that has been the stride throughout mankind. Now, if we look at the story of measurement and what we've been doing over the years, let's go to Egypt. And when they built the pyramids, how did they do that? Well, they had two sites. They had one site where they made the stones, and they had another site where they erected the pyramids. And how did they communicate so you got the right size stone for the right pyramid? Well, they had something called cubits, and that's the distance between your fingertip and your elbow. And the Great Pyramid of Giza, for example, is 440 cubits tall. Now, if you fast forward some 3,500 years into the future, we end up in the Middle Ages. Food was hard to get by, and life was tough. So you had to economize with your resources. And they invented the furlong, and a furlong or furrow long was a measurement, a distance measurement. And 40 furlongs was exactly what a pair of oxen could do to pull a plow before they needed a rest. And then again, if we fast forward to the year of 1593, when Queen Elizabeth I reigned United Kingdom, she decided that a mile shall be 5,280 feet. Why? Because it's exactly 8 furlongs. And with that, you Anglo-Saxons signed your destiny, and the imperial measurement scale was born. And I live in England, and it's very, very puzzling when you come to a petrol station and you fill up your car in liters. And then you try to calculate what distance can I do with that, and then you have to switch to miles per gallon. But history continues, and if we fast forward another 200 years, we have a bunch of people that like to decapitate kings and queens. They also didn't like the imperial measurement system. Do you know who I think of? The French. Parbleu! We need another system. We can't use Queen Elizabeth's measurement system. And they indeed invented the metric system. You didn't know that. A rowdy bunch of people decapitating other people. They also had time to do this. And the way they set it up was a meter is 1/10 of a millionth of the distance between the equator and the North Pole. Today, we measure using the speed of light, and what you see here is exactly a meter expressed in the speed of light. So that is the story of measurement. And to measure is to know. Now, this was uttered by Calvin Klein just before he designed his underwear brand. And now I got it wrong. It was his brother, Kelvin. Kelvin said this, and this is true. And this is exactly what we've been doing at Hexagon. We've been measuring cities, large metallic objects, infrastructure. We have autonomous measurement devices. We invented the point cloud. Now we work with heavy industries. We work with high-tech industries. And we put food on the table for you through measurement technologies in agriculture. And today, you could say it's our 25th anniversary as a company. And when I look out at this auditorium, and I can even look up there. Oh, I didn't see you. There's a lot of people up there as well. Anyway, I see people that have been customers, partners, and employees of this company. And maybe your relationship with this company stretched back 5 years or 15 years. And I even see faces in the crowd. that were at Brown and Sharp back in the year 2000. And we have a very special relationship with this company, but let me recap the history just for you for a bit and think through what we've done. So we started by focusing on capturing the real world through sensors. And with Brown and Sharp, we got tactile sensors like touch trigger probes, scanning probes, and so on. In 2005, we added Leica Geosystems, and we started talking about EDMs, lasers, radars, and point clouds. And in 2008, we acquired Novotel, and now we have the ability to measure down to 5 centimeters accuracy using a satellite up in the sky. But by the end of the decade, it was clear that there is an even bigger opportunity for productivity enhancement, and that is bridging the physical world with the digital world. So in 2010, we acquired Intergraph. And with that, we created a new business model, and it looked something like this. Think that you have an object that you want in a blueprint. So you scan it using probably laser scanning, and you import it into a piece of application software. Suddenly you can visualize it, you can simulate it, you can make it better, you can make it prettier, whatever you need to do. And that can then act as a remedy to impact the real world. And it becomes an endless feedback loop of data going back and forth between the digital world and the real world. Little did we know in 2010, but today we call it digital twins. And this is a true watershed moment for most industries, from medtech to mechanical engineering, electronics, and so forth. You can now use your capacities in the software world to simulate and make better before you make the actual experiment. And this reminded me of a super interesting digital twin. Shortly after we acquired Intergraph, a man, and his name was Dr. Andrew Tallon. He bought a Leica scanner from us. And he was very interested in Gothic churches. And he had the permission to scan the Cathedral of Notre Dame in Paris. And he worked very hard scanning this cathedral. He probably collected like 2-3 millions of points about the cathedral. And what happened next? Well, not much. Until an April in 2019, an April morning, when the cathedral catches fire. And the entire roof structure implodes over the cathedral. And this landmark of French beauty is gone forever for all of us, we think. But then someone remembered Dr. Andrew Tallon that had done these scans some 9 years earlier. Unfortunately, Andrew deceased. He died from cancer 6 months earlier, so he never got to know how important his work was. But his widow had saved the scans and gave that to the project team responsible for restoring Notre Dame. Now something fascinating happens. Suddenly we can communicate with people that have been dead for 800 years. Artisans, stonemasons, carpenters. We could see their craft, their work into nitty-gritty details, and they could reconstruct Notre Dame exactly how she was erected 800 years ago. And in December of last year, she opened the doors again to the general public, and you can now see Notre Dame. That's pretty powerful about digital twins. So, what do you learn from this and from the past 25 years? What I've learned and what I've always believed in is the only constant in life is change. You have to change. We've lived through financial crisis, we've lived through COVID and all sorts of things. A company, an organization, and we as individuals must always learn and change. And late last year, the board of directors decided to spin off ALI and SIG into a separate division, a separate company, forming a publicly listed company independent to Hexagon. And let's watch a little video about that. I think it's a great name. Question is, how do you pronounce it? So what I've learned is if you're English, you say Octave. If you're Australian, you say Octave. Right, David? Now, let's talk about Octave. And who better to do it than the man, the champion, and the future leader of Octave, Mattias Stenberg.
Thank you. Wow, you brought a lot of people, Ola. Nice. Well, thank you very much for inviting me. And what do you say? Before we start into the presentation here, I have something I have to tell you.
What?
It's a bit awkward, to be honest, but I want
all these people watching.
Okay, yeah, shit. No, but I wanted you to be the first to know. You know, we worked together a long time, but I'm leaving Hexagon.
That's actually excellent news, because I've been figuring out a way to get rid of you, but
ouch.
You're the sticky kind. But I do see that you leave on a high note, so good luck.
All right. Thank you. I see what you did there, Ola. That's clever. Yeah, you're going to get tired of the music references pretty soon, I think, but I like them a lot. And I am super excited to be here today. I'm very excited to tell you about Octave. But before I do that, I thought I'd share a little personal story, right? It's a bit of a bittersweet moment for me, I guess. I've been with Hexagon 17 years, so not all of the 25 years like Ola, but still a pretty long time, right? I started in Stockholm, Sweden, where I'm originally from, as investor relations manager. That was my first job. And the good thing about investor relations is that you get to meet the boss very early, right? Because you need to know the story. So my first week on the job, Ola came up to me and he said, "Oh, you're the new investor relations guy. Here, come with me. You might learn something." And we got in a car and we drove to this event where Ola was presenting to a big group, maybe not this big, but still big group of investors and shareholders. And we talked a lot in the car there and in the car on the way back, and I thought this was, going well. And then he turns to me and he says, "Why are you here doing investor relations?" And I thought, shit, this is not good. I'm getting fired the first week on the job. But then we got to talking a bit more, and I understood that he meant, investor relations is all good and fine, but I think you can do bigger, better things for us. And that's really been the story of my career. I've done a lot of different roles in Hexagon. I was head of strategy and M&A for several years. I moved around the world, different places. Right now I live in Huntsville, Alabama. And I've been running the ALI division for the last 8 years, and now getting this opportunity with Octave. And so I wanted to take the chance here to say thank you to Ola for his mentorship and his leadership. What a fantastic journey it's been, Hexagon, truly amazing. And now, though, a new journey begins, right? We are introducing Octave, unleashing intelligence at scale. And the most common question I get a lot of questions, but the most common one is why? Why are we doing this? And you can say a lot of things about that, but if you have to dumb it down to one thing, I would say it's focus, right? To sharpen the strategic focus, accelerate growth, and ultimately unlock greater value for both companies, Hexagon as well as Octave, right? That's the goal. So what does it include? Well, we're combining 4 leading software companies. ALI, with its portfolio of design, construction, operations, and asset management software, right? SIG, the clear leader in public safety, physical security, and geospatial solutions. And in the quality space, you know, analysts rank ETQ as the world leader. And finally, of course, we have our rebel disruptor in the CAD space with Brixis. So I think by combining these capabilities, we're raising the bar, taking the company to the highest level, or if you want to be clever, we're taking it up an octave. Right? So you see what I did there? Yeah? Okay. And as an independent entity, Octave will have the flexibility to focus on our own operating strategies, accelerate innovation, and frankly also establish a powerful platform for future M&A. We're not done. So while our name is new, our commitment to you, our customers, is unwavering, right? I promise you that we will not miss a beat when it comes to that. The company will have initially about 7,500 employees, revenue around 1.5 billion euro, solid profitability, and very high recurring revenue. So I think it would be a very attractive and cool company. And what I also tell people internally a lot is those numbers, they're all good, but that's the smallest we will ever be. We will continue to grow. Okay. So you could say Octave will be a unicorn company from day one. Pretty cool for a startup, right? And I do think it's a once-in-a-lifetime opportunity for our employees, our customers, our partners, and also for our investors and shareholders. And I guess for you guys here today, you get the chance to really see day one of this company. So I think that will be a really cool thing in, who knows, 5, 10, 20 years from now. Okay. So what businesses are we in? What are we doing? How do we define the space? We're in the business of designing, building, operating, and protecting the world's most mission-critical assets, including, but not limited to, energy and processing complexes, electric generation and grid infrastructure, advanced production facilities, critical transport hubs, and mission-critical data and control centers. And what's our reason to exist? What's our unique selling point? Well, to me, the advantage we have in this company is that it will be truly born digital, right? We will be a software-first company. We will orchestrate your data live across the entire life cycle of an asset. The intelligence is built in, not an afterthought. It's cloud native, built for scale, right? So always on. And like I said, our solutions are targeted for those assets that ultimately must not fail. So to sum it down, bottom line, Octave will deliver intelligence at scale. So what's next, you might ask? Well, Our timeline is to launch this company into the stock market, we say, early next year. And I hope all of you in this room will join me on that journey, either as employees or customers, partners, or who knows, maybe investors or shareholders. I also hope that you will join me back here in about a little more than 2 hours, because I do have a lot more stuff I want to tell you about Octave that I couldn't fit in here. So can I count on you guys to be back here in 2 hours? Yes? Come on. Yes? Great. I appreciate that. Thank you very much for paying attention, and thank you, Ola, and back to you. All right.
Thank you.
Thank you.
I'm sure you and the Octavians will do really great. And I was just standing here looking at the logo, and if they want to copy HXGN Live, it's going to be like CTV. But that's a different story, because now we're going to talk about Hexagon. And I want to talk about Hexagon today, and then I would like to move into the future and see what we can do next. How do you describe Hexagon? What do we do? And I've very often gotten that question at dinner parties and so on. And then I say, we're the world's most sophisticated measurement tape. And then typically they yawn and we do something else. But if they're really interested in this measurement tape, and they're slightly intrigued in measurement tapes, I'll say, well, it doesn't look like your measurement tape. This is what our measurement tapes look like. So to the left, you have an ultra-high accuracy coordinate measurement machine. Say that after 2 glasses of wine. Very difficult. What can it do? Well, it can measure down to 1/10 of a human hair in accuracy. And it's impossible to make sophisticated electronics or medtech without it. Now, in the center, you have a robotic total station. Without modern robotic total stations, we can't build long tunnels, bridges, or high-speed rail. And to the very right, you see this white puck. That is a GNSS or GPS receiver. It receives satellite signals from 20,000 kilometers altitude, and it can measure or position down to 5 centimeters accuracy. Now that's a measurement tape. Now, what can you use it for? Why do you need these measurement tapes? And I thought we'd do a little odyssey around the world of our customers. And we've chosen a few examples from you that are like between 6 and 18 months old. So let's start with Firefly. Firefly is a fairly new company, and it's incepted here in the United States. Their idea was to build like a shuttle bus. But this bus is not going to school, it's going to the moon. So it's going to travel 240,000 miles. It's going to carry a lot of experiments with it. It's going to perform the experiments as it lands on the moon, then fly back and report. And then you refuel, you recharge, and off you go again. So it's going to be almost like a link, a constant connection between Earth and the moon. And they testified that they've just finished their first fully successful commercial moon landing and return. And they said, we couldn't have done this without your precision technologies in the manufacturing phase. Now, next I'd like to go to Saudi Arabia, and let's go underground and discuss mining for a bit. In Saudi, we have a company called Ma'aden. And Ma'aden is the first digital mining company in the Middle East. They've standardized their procedures on all our tools. And they began to see quite early a 4 to 8% cost reduction in their operations. And that gave them the confidence to scale up operation, and they're now going to double size and output. So let's hear it from Ma'aden's CEO.
Hi, I'm Bob Wilt, the CEO of Ma'aden. Ma'aden is the Saudi Arabian mining company, been in existence for about 27 years. The last 5 years, we've been the fastest growing mining company in the world. Any mega trends you look at, mining is essential. We feed the world. If you fly in an airplane, you drive a car, we're in everything you do. Think about what's going to be required as far as metals and minerals for the future. We'll need 6 times as much copper at least. And historically, to construct a mine and a processing plant, it took about 20 years on average. We need to shorten that cycle time at every step of the way. And technology is imperative in the mining industry, particularly right now as we're on the cusp of an energy transition. So every step of the value chain, we've got to cut costs, cut cycle time, and do it faster if we're going to meet the global demand for metals. And the only way we can do that is through technology. People don't often equate mining with technology. We don't send people down underground with pickaxes and flashlights to do manual labor anymore. We have digital technology, automation, remote sensing, people working in control rooms. So our partnership with Hexagon is unique as we are trying to create the first digital mine in the Middle East. And Mansoura Massara is our newest gold mine. And Hexagon is helping us digitize that.
Impressive, huh? Well, not just the technology he's been working out, right? Now, next I'd like to take you to Liverpool. Who is an Everton fan here? Do we have any Everton fans? Silence. Poor Everton. Anyway, Everton is based in Liverpool, and like all football clubs, they're struggling with the finances, right? But they needed a new stadium. And they contacted Lang O'Rourke to construct the new stadium, and they contacted us. And they wanted to do a very different project building this stadium. They wanted to cast a huge concrete slab, and they wanted Hexagon to measure that slab to make sure that the difference wasn't more than 1 to 5 millimeters. And then jointly they made and we measured 8,000 pieces that were made, pre-made off-site. And then it became like a Lego, where they assembled these 8,000 structures, and it worked really, really well. They saved 50% on construction hours. And it's a bit secret, but it's like 30 to 50% lower production cost for this stadium. And in December of 2024, it was inaugurated. And we now play football at this stadium. So a really good success story. Now, next we should visit Norway. What is Norway famous for? Apart from being the neighbor to the glorious Kingdom of Sweden. Now, if you look at the map, Norway is a very long country and a very narrow country. It's full of mountains and fjords that is penetrating the country from west to east. And it's literally impossible to go by land or by car or by train from city to city. But there is a silver lining, and we call them the Arabs of the North, because they found oil in the 70s, and there is nothing the Norwegian government can't afford when it comes to Norway. So we're going to talk about a new project called the Rogfast Tunnel. It's a 27-kilometer long tunnel built 400 meters under the surface. And it's going to halve the time that it takes to travel from the 2 second largest cities of Norway. Now, what's important when you build a tunnel? Well, like 100 years ago, when Leica was helping building tunnels in the Alps, the trick was to at all meet. Because when you build a tunnel, you start here with one team, you start here with another team, and then you dig and dig and dig and dig, and finally you shake hands and you meet. That's when you have your tunnel. Today we've advanced quite a bit when it comes to measuring technologies. Now you talk about something called alignment accuracy, and it's measured in centimeters over these 27 kilometers. And every centimeter of deviation is an extra cost of $100 million. So now we're going to hear it from Skanska, the construction company that did the digging.
My name is Trond Valør, Vice President in Skanska, Norway. Traveling in Norway takes a lot of time. It needs to be efficient. So it's highly important that we build really good roads so we take down the time between the cities. Very important cities for the oil and gas industry, also for the local community.
The project Rogfast is really special. The whole project covers 27 kilometers, 2 tubes of tunnel. It's a very challenging project.
We are building a tunnel from 2 sides, 300-400 meters below sea level. We're gonna meet up another team in the middle, and that is extremely hard. Hexagon technology is our eyes in this project.
We use the scanners from Hexagon every day. With the technology we have today, it's possible for us to meet within 5 centimeters. We are blind if we don't have the technology.
There is no room for errors, and for that it's crucial to have equipment from Hexagon, like total stations, GPS, multi-stations, laser scanners. It allows us to measure much more efficiently. Without the collaboration that we have with Hexagon, this project will be impossible.
We are totally depending on Hexagon technology to do our work right the first time.
With the collaboration with Hexagon, that allows us to be in the forefront of the innovation.
Hexagon helps us to do it right the first time.
That is pretty impressive, isn't it? But it doesn't stop there. What more can we do? Well, we work with discrete manufacturing, and anyone that is in discrete manufacturing knows that it's fairly easy, I wouldn't say easy, but it's okay to make a prototype. But the tough job starts when you're going to scale from a prototype to making millions of products. And we assist manufacturers of mobile phones, cars, planes, and so on. They all use our technology to scale up. And in this case, I want to talk about Volvo that launched a new car earlier this year. The way they did it to go from prototyping to scaling up to making hundreds of thousands of cars per year is they made 80 precision tools. And each tool will make 1 million parts. That's 80 million parts in a year that needs to come together at the assembly line and fit the first time to reach your productivity rates. And this is a very cumbersome process. It usually takes a year until you're up and running. They used our laser trackers and they cut the process in 5 months. So really good outcome for Volvo. Finally, what more can you do with our measurement tape? Well, I've been traveling an awful lot in my working life, and I bet you have too. And sometimes when you sit in that plane seat and you're about to land. You look out the window, and then you see the problem because you don't see anything. It's just white. It's full of clouds and fog and everything. And then the plane starts rattling a bit, and you hear that sound that you've never heard before. And did that sound really squeak the way like it does all the journey, or is it a new sound? And you start to get worried. Now, fear not, because now I'm going to tell you how it works at most commercial airports. At 3,000 meters altitude, Hexagon's positioning systems catches the plane and guides it with centimeter precision towards the runway. So the pilot doesn't need to see the runway. The systems will do it for him or her. So that is really, really good. And this is just a snippet of the things we work with you, our customers, day in and day out. And it's pretty amazing. But there are other things we care about in life, right? So in 2019, I stood on a stage here in Las Vegas, and I asked the rhetorical question, can data save the world? And I claim that saving the world is probably the biggest business opportunity in the next 20 years. What did we do after that? Well, not much, because COVID happened and we were all locked in, and we started with working from home and so on. But when we came out again in February 2021, then we launched a company, fully owned subsidiary of Hexagon, called Our Evolution. And we hired energetic Eric to run it for us. And anyone that has met him knows that he is super passionate about this. And since 2021, we've built solar parks and improved the efficiency of those parks in Spain. We've helped reducing the footprint, the CO2 footprint for desalination plants in the Middle East. And we've saved the seagrass forests of the Bahamas using sharks as scanners. So it's been a really interesting journey, and we use Hexagon's technologies to deploy in activities where we can make the world better and make money on it in the process. And next, we have one of the biggest opportunities ever for our revolution, and it's called green cubes. Now, what is a green cube? A green cube is a way of digitizing assets that the nature has. And the big problem is that I'm roughly 30 years old, times 2. And when I was born, if we compare the biodiversity in the 1960s to today, 70% has disappeared. It's gone. And now it's time to start to restore it to save this planet. And in this case, we have teamed up with the largest iron ore mining company in the world, Vale in Brazil. And they have put aside $3.1 billion to restore 50,000 square kilometers of forest. And the way we're going to do it is to digitize this area. And the way technically it works is that you use Earth observation, and then you move into airborne LiDAR. Now we capture the forest in 3D. We go into the ground, and we use terrestrial LiDAR to capture that. We can even go underground and see the root system and the quality of it by using ground-penetrating radar. Eventually, you fuse all this data into an information system which looks like this. And each little cube, it's roughly this size, will be priced at 10 cents. And if you buy a cube for 10 cents, you're going to protect it forever. Vale is initiating it, and for the proceeds that they make on these green cubes, they're going to buy more and more land. And it becomes a positive spiral how it's going to work. So now I thought we would visit Brazil and talk to Yosara on ground there, what she has to report.
Hi, Ola. I'm here in the Atlantic Forest in a valley site near Belo Horizonte in Brazil. Together with Hexagon, we are making nature visible using green cubes. We can now track and report on flora and fauna, we can understand and protect biodiversity, and we can engage with the community through education and action. And just a few days ago, we've spotted some pumas for the first time in over a decade. We are changing the game together. Back to you, Ola.
Thank you. Really good. So to measure is to know, and if we do this in a precise manner and monetize the natural assets, put a price on them so that you know what they're worth, I believe we can still turn this around and save the world. So this, my friends, is Hexagon today. But where are we going tomorrow? Well, for those of you that have been to Hexagon Live in the past few years, you've seen two things. You've seen the dog, we call it, our autonomous sensor that can walk and scan. And you've also seen the drone, where you pre-program a flight path so you don't need a pilot to drive it. We've also been working for a long time with industrial robotics to measure large-scale manufacturing. Now, if you combine that with the capability to capture the world in 3 dimensions and create 3D worlds, in this case it's New York City, it's millimeter accuracy in these pictures. We have captured countries doing this. We've captured important infrastructure, and in Germany, we've captured the entire rail network for Deutsche Bahn, for example. Now, when you fuse autonomous sensors, 3D environments, you throw in data to train on, and you write AI algorithms, then you can reach true autonomy. And you might sit there asking yourselves, why? Why is true autonomy important? Well, we're worried. We read about AI taking our jobs, we read about robots taking our jobs and so on. But it's actually the opposite. I have to ask you a very personal question. Who in the audience have 2 kids or more? Good on you. Yeah, you're thinking about the future. Because now we're going to look at the reality. And the reality is that if you take the population of the United States and we freeze our behavior as it is right now, the US population is going to shrink from 340 million people to 225 million people in the next 70 years. Europe isn't better. So Europe looks like this. We're going from 750 million people down to 550 million people in the same time frame. And if you dissect this population development and you look at the demography, and we use China as an example, China is actually the worst of them all. Now, the yellow is the number of retired people in the population, and the blue is the workforce aged 15 to 64. By 2078, you're going to have more retirees than the total workforce in China aged 15 to 64. Now, this causes a problem. So if you now start thinking about your everyday lives, you pick up a cup of coffee on your way to work, you work in office environments, go to cantinas, and so forth. Who's gonna plow the fields and so on? We have a huge problem ahead of us, and we need to address it. And scientists and journalists alike have started to see this problem, and they've started to do calculation and simulation models. And if we don't find solutions to this, we could actually halve the global GDP. And it's time to act. So at Hexagon, we're proud that we launched our latest division, and it's called Hexagon Robotics. And we're going to look at a little video.
Please welcome Arnaud Robert.
Thank you, Ola. Good morning, everyone. Great to see
Welcome.
you.
Take it away.
I will. Thank you. Let me start with putting a bit of context. Automation has gone a long way in the last 10, 15 years. There are two main drivers of this. One was stationary robots, the ability to complete a task with extremely high accuracy, efficiency, and speed. The second big driver was AMRs, as the name suggests, a certain level of autonomy and, I would say, mobility, but in the defined context, usually of warehousing and logistics. So to reach the level of autonomy that Ola just mentioned, we need to move beyond automation into versatility. Versatility requires robots to do two things: be multi-purpose and adaptable. Multi-purpose, for example, the same robot should be deployed to move boxes around a factory, or the same robot should be deployed to inspect an automotive part and find defects. Completely different tasks. They have to be adaptable. One day, they need to be sorting small pieces, screws, bolts, which require high dexterity. And the next day, they need to sort large parts, bulky parts from the engine, for example. They have to adapt. Sorting, but two different types. We created the robotics division to effectively capture the promise of autonomy that Ola described, and to build versatile robots. Our vision is quite simple. Build an autonomous future, one humanoid at a time. Now, when people see this, they focus straight to humanoid. Why humanoid? There are many different form factors. Two fundamental reasons why we think humanoid is a solution. The first one is that the world, as we know it, was built by humans for humans. And so a form factor that can integrate directly into the vast infrastructure we have, factory, manufacturing, and so on, is a great advantage. The second reason is that if you look at advancement in physical AI, specifically to enable versatility, the biggest promise is imitation learning. Imitation learning is when you teach the robot by doing versus programming. There is no better way to do this, to translate the knowledge of a task that needs to be completed, if the teacher, the human, and the student, the robot, have a similar form factor. Because every gesture you do for training is directly transportable to the robot. Otherwise, it gets actually quite complicated. So, humanoids, we believe, are the solution. Today, we are beyond thrilled to introduce the first versatile humanoid from Hexagon. It all started actually about 2 years ago from an idea from our visionary chairman, Ola. Since then, we made a bit of progress, and without further ado, let's introduce Aeon.
It's time for Aeon. Agile, versatile, aware. Agility, to work with dynamic precision. Versatility, learned through experience in real time. Awareness, through spatial intelligence, to sense, recognize, and take action. It's time. Let's get to work. Aeon.
There we go. Yeah, come on. Aeon is truly a marvel of engineering, and I think, Ola, we're a big step towards autonomy. With the
Super impressive, Arno. Yeah. When do you think we could see one for real?
Okay. I would say now.
Sounds good to me.
Right. What do you think? Yes? All right. Let's get Aeon. Excellent. Let me talk about Aeon just for a few seconds, and then maybe we can engage with him a little bit.
Absolutely.
You'll notice a few different things. First, it has wheels. Second, but of course, you saw it. Second, it has bionic hands for dexterity. The third thing you might notice, it has 2 batteries. So we developed a really interesting system where we can do self-swapping of batteries for continuous operation, which has been a bit of a challenge actually in the humanoid space. What you cannot see is that inside, there's actually 3 different computers. The first computer is a general computing engine. The other 2 computers are actually AI engines to do everything we can from an AI at the edge. Very critical, obviously, for autonomy, that the robot can do most of it on its own. And the last piece is at the head, although that's the highest concentration, but there's a few others elsewhere. We have 22 different sensors in the robot. 12 different cameras. They look at the periphery of Aeon. They look in front, they look in the back. We have AR cameras to understand heat around the room, to understand people, etc., and a number of other sensors. We think that's a differentiating factor. All of these actually combined is quite differentiating with what we've seen in the market. And frankly, it's a big step towards versatility, because once you have those sensors, not only you have awareness, like we showed in the video, but frankly, more importantly, a lot of use cases are unlocked with those sensors. Reality capture, asset inspection, and so on. So we're quite proud of the engineering feat that Aeon is.
Amazing. Aeon, can you introduce yourself?
Hello, my name is Aeon, and I am a working humanoid from Switzerland. I was designed to complete industrial tasks such as manipulation, part inspection, and reality capture. I am excited to be here today at Hexagon Live.
Excellent.
Amazing.
Nothing.
Now, Arno, you and I are casually having a conversation here in front of 3,000 people. So I prepared a few questions for you.
I think it sounds good, yeah.
When do you think Aeon can work alongside people?
Great question. So Aeon was truly designed and built to work alongside the workforce. I think you've talked about aging population. What we also hear from many industry leaders is that there are other workforce challenges, labor shortage, and so on. So the world actually needs humanoids to complete a number of tedious and repetitive tasks, as an example, across many different industries. So we think this is a great solution to complement the workforce, actually.
Amazing. Why the wheels? Why not
the wheels? Yes, most of you probably, if you know humanoids, have feet. That's where we started. Actually, we started with feet. Then we decided to try belts. At the end of the day, the most efficient locomotion mechanism, when you think about going forward with a certain speed, you saw it coming out, it can go backwards, it can pivot quickly. And we tried, I would say, quite a few different configurations, and the wheel is by far the most efficient mechanism we have.
Amazing. Can we see it breakdance?
Well, we actually, in honesty, we actually did teach the robot a few dancing moves. Engineers like to, play with robots, of course. But we decided actually that the real focus of the robotics division was to bring business value to our customers. And so we're focusing a little more on manipulation, asset inspection, reality capture, than we are focusing on breakdancing. So I will have to disappoint you on that one.
Okay. So when do you think we'll see it working in society?
Actually, a good plug, maybe, if I may. There's a general session at 4:30 today, where we're going to tell you quite a bit more about Aeon in terms of capability, use cases, and so on. And one of the things we will disclose this afternoon is that we have 2 pilot customers that will test Aeon across a number of use cases: manipulation, machine tending, reality capture. And so we will keep that secret until 4:30 to make sure that you all come back at 4:30, right? No, we're very excited that we're already having Aeon deployed in the real world.
Amazing. Let's get to work. Thank you, Arnaud, and thank you,
great.
Aeon.
Excellent. Yes. Thank you. All right. Thank you, everybody. All right, Aeon.
Bye-bye. Yeah. No, on a serious note, this is a super interesting technology, and we've come a long way. We haven't used much resources, but we've used the technology that Hexagon already had. And the wheels are just fantastic. It can swap its battery and its legs by itself. And obviously, the head contains all the measurement technologies for spatial intelligence. So we're going to see much, much more of Aeon. But with that, I think we've wrapped up this keynote. And if there's one thing I want you to remember when you're sitting there at a dinner party, this is the world's most sophisticated measurement tape. Thank you, everyone, for listening, and have a great show.